Hey everyone, today we're going to talk about the difference between independent and dependent events. So first, an independent event is when the outcome of the first event does not affect the outcome of the second event. Okay? So like if you flip a coin and then spin a spinner, whatever happens with the coin is not going to change what could happen with the spinner. Okay? Or if we're dealing with something like marbles in a jar, okay? If we take something out and we put it back before doing the next thing, okay, whatever happens first is not going to affect what could happen second. Okay, so let's take a look at some examples. So it says if you pulled a marble out at random, then put it back, so you replace it before you pull out the second one. So question 1 says, what is the probability of pulling a green marble, replacing it, so putting it back, and then pulling a red marble? Okay, so what we have to do first is find the probability of green. Okay, so remember, to find the probability, we need to know the total outcomes, so how many total marbles there are, and if we count them, there's 20. Then we want to find out how many of those are green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 green. So 10 out of 20, remember, we could simplify that. Okay, that is equal to half. Now we want to find the probability of a red marble. Okay, so I took out the first one. I see what color it is. I put it back, so there's still 20 marbles. Then the amount of red, 1, 2, 3, 4, 5, 6, 7, is 7 out of 20. So to find the probability of both things happening, remember we can multiply the probability of the first event, 1/2, times the probability of picking red, 7 out of 20. And when we multiply, remember we go straight across, so 1 times 7 is 7, 2 times 20 is 40. And then we look to see if we can simplify. 7 out of 40 cannot be simplified, so the probability of picking green, putting a marble back, and then picking red is 7 out of 40. All right, let's look at our next one. What's the probability of pulling a blue marble, replacing it, and then another blue marble? Okay, so first we need to find the probability of blue. So there's 20 total. If we count the blue, we see there's 3. Then I'm going to put the marble back. And so the probability the second time, there's still 20 marbles. There's still 3 blue. So then we can multiply. 3 times 3 is 9. 20 times 20 is 400. That cannot be simplified, so the chances or the probability that you pick a blue marble and then another blue marble is 9 out of 400. So it's unlikely going to happen. Let's take a look at a few more. So Miss Little has 8 boys and 10 girls in her class. She picks a student each morning to take her attendance. What's the probability that she picks a boy 2 days in a row if the popsicle stick is replaced? Okay, so the first day, we need to know the probability of picking a boy. There's 8 boys, there's 18 students. Okay, remember, if we simplify that, we can divide them both by 2. So we can get 4 out of 9. Okay, the popsicle stick, so she picks the first one, she puts it back in the cup. Okay, so then there's still 18 to choose from the next day. The boys is still 8 out of 18. Remember, it simplifies to 4 out of 9. So then we multiply. 4 times 4 is 16. 9 times 9 is 81. Okay, so we have 16 out of 81, and that cannot be simplified. So the probability of her getting a boy 2 days in a row is 16 out of 81. So again, it's unlikely going to happen. Okay, this one says a jar contains 6 blue, 4 red, and 3 green marbles. What's the probability of selecting a blue marble 3 times in a row if you replace it each time? Okay, so we have a blue marble, pick a blue marble again, and pick a blue marble again. So 3 times. So the probability of blue, there's 6 blue. If we add them up, 6 plus 4 plus 3, there's 13 total. Okay, we're putting it back each time, so that probability stays the same. Okay, so we have to do 6 times 6 times 6. So 6 times 6 is 36. And then 6 times 36 is 216. And then we have to do 13 times 13 times 13. And so we get 2,197. Right? And then when we, I don't think that can be simplified, so that is our answer, 216 out of 2,197 times. Okay, so that's a probability of picking a blue marble 3 times in a row. Okay, so those are all independent events, okay, because whatever happens first is not going to change what could happen after that because we're always putting the item back. Now let's take a look at dependent events. So dependent events are when the outcome of the first event does affect the outcome of the second event. Okay, so if you pull a marble out at random and then keep it, so it means without replacing it before you get the second one. Okay, so let's look to see how this changes our answers. Okay, so the first one says, what's the probability of pulling green without replacing it and then pulling a red? Okay, so we have to find green and then we have to find red. So remember, there's still 20. Green was 10 out of 20. Remember, so that's 1/2. Now we're not going to replace it. So I took a marble out of the jar. So now when I'm trying to find the red, there's only 19 marbles in the jar now. Because remember, we took the first one out. Okay, so now if we look at the red, there's 1, 2, 3, 4, 5, 6, 7 red. Okay, so now we can multiply. 1 times 7 is 7. 2 times 19 is 38. Okay, and that cannot be simplified. So you have a 7 out of 38 chance of picking a green marble first, not replacing it, and then pulling a red marble. Okay, let's take a look at another one. So the probability of blue, not replacing it, and then another blue. Okay, so we need to find out the probability of blue and then blue. Okay, so the first time there's 3 blue and there's 20 total. Okay, now for the second one, if I took a blue marble away, there's only 2 blues left. Okay, and since we took one away, there's only 19 total marbles left. So now, picking the first marble is changing the probability of what we could get for the second blue marble. Okay, so we still multiply across. So 3 times 2 is 6. 20 times 19 is 380. Okay, we could simplify that by 2, and we could get 3 out of 190 for the probability of picking a blue, not replacing it, and then picking another blue. All right, let's take a look at a couple more. So here it says, in a cage at the San Diego Zoo, there are 3 black cats, 4 white cats, and 2 striped cats. If 2 cats escape from the cage, what is the probability that both cats are white? Okay, so we have to do white and then white. Okay, so total, there's 3 plus 4 plus 2, so there's 9 cats total. Of those, 4 are white. So if the first cat that left is white, okay, that means there's 8 cats remaining, and out of the 8 remaining, only 3 of those are white, because 1 white cat already escaped. Okay, so this is dependent, because whatever happens first, okay, the second one depends on it. So then we can multiply across. 4 times 3 is 12. 8 times 9 is 72. Okay, we could simplify by 4. Okay, if I simplify by 4, 12 divided by 4 is 3. 72 divided by 4 is 18. And then we could actually simplify that again, okay, by 6. Or no, by 3. Okay, and we get there's a 1 out of 6 chance that both cats are going to be white that escape. All right, so back to our popsicle type example. So we still have 8 boys and 10 girls. She picks a student each morning. What's the probability she'll pick a girl on Monday, not replace it? So that means she's keeping the stick because that student cannot be picked again for that week, and then picking another girl. Okay, so a girl the first day and a girl the second day. So the first day, there's 10 girls and 18 total students. Okay, remember if we simplify that, that's 5 out of 9. Now, the first time that popsicle stick was taken away, okay? So a girl stick is taken away, so there's only 9 girls left. There was 18 total, but 1 was taken away, so now there's 17 left. Okay, so now when we multiply across, 5 times 9 is 45. 9 times 17, I think it's 153. Okay, and then to simplify, we can simplify by 9, and that's going to get us a 5 out of 17 chance of picking a girl the first day, not putting it back, and picking a girl the second day. Okay, so that second day depends on whatever happens first, okay, because we have less sticks and we have less girls available. All right, so I want you to give these a try. So first, try to identify is each one independent or dependent, and then find the probability of that event happening. Okay, so pause the video, try these 3, and then come back to see how you did. All right, let's take a look at the first one. It says Michael flips a coin and rolls a dice. Find the probability that he flips heads and rolls a 6. So is flipping a coin going to change the probability of rolling a dice? Okay, no. So it's independent. Okay, so now heads, okay, the probability of getting a heads is 1 out of 2, since you only have 2 outcomes, heads or tails. Okay, rolling a number cube, our outcomes are 1, 2, 3, 4, 5, 6. Okay, so rolling is 6, you have a 1 out of 6 chance. So to find the probability of both things happening, we need to multiply. 1 times 1 is 1. 2 times 6 is 12. So you have a 1 out of 12 chance of picking a heads and rolling a 6. Here, our next one says, Alex has a bag of marbles. 5 are green, 3 are blue, 2 are red. What's the probability that Alex pulls a green marble, puts it in his pocket, so it's not going back, and then pulling a green? Okay, so we have a green, not replacing it, and another green. So that is dependent. Okay, because whatever happens first is going to change what could happen second. Okay, so now finding the probability, we need to find green and then green again. So there's 5 green. It looks like there's 10 total. So 5 out of 10, which is equal to 1/2. But the second time I try to get green, okay, the first marble I put in my pocket. So now there's only 4 green left and 9 total marbles left. So then when we multiply, 1 times 4 is 4, 2 times 9 is 18. We can simplify by 2, and we get to 9. So the probability of picking a green and not putting it back in another green is 2 out of 9. All right, number 3, a bowl of fruit is on the kitchen table. It contains 5 apples, 2 oranges, and 2 bananas. Christian and Aaron come home from school and randomly grab 1 fruit each. What's the probability that both grab an orange? All right, so we need to think about this. Okay, if the first person grabs a piece of fruit, is he going to put it back for the second person, or is he going to keep it to eat? Okay, he's going to keep it to eat. So this is dependent. Okay, they cannot grab the same piece of fruit. So the first time, okay, we want to find the probability of an orange, and then the second time, probability of an orange. Okay, so the first person has 2 oranges to pick from out of 5 plus 2 plus 2, 9 total. Now the second time, okay, if the first person took an orange, there's only 1 orange left, and there's only 8 pieces of fruit left. Okay, so if we multiply across, 2 times 1 is 2, 9 times 8 is 72. Since they're both even, we can simplify by 2, and there's a 1 out of 36 chance that they both grab an orange. All right, so that's going over independent and dependent probability. Okay, if you head back to Schoology and complete your other tasks, okay, you'll be done for today, and we'll see you again tomorrow. Have a good one.